Okay, let me start then. 6.2, I will do some exercises before I do the calculus part. For example, 6.2, let me call it part A, exercise for part A. Let's say number 8. Number 8, y equals to 0.5 to the x minus 2. The question is, make a rough sketch of the graph. Do not use calculator. Do not use calculator. Well, we start from 0.5 to the x because the base is between 0 to 1. So it must be decreasing. Right? It must be decreasing. Now then 0.5 to the x minus 2, you basically move that graph down 2 units. So the asymptote originally y equals to 0 now becomes y equals to -2. Okay. The x-intercept originally 0, 1. When you move it 2 units down, it becomes 0, -1. In fact, I think we can find the x-intercept. Can we? I think we can find the x-intercept. Yeah, we have the y-intercept 0, -1. The x-intercept means the y has to be 0. The y has to be 0. This is 1/2 to the x minus 2. This is x. So 2 equals to 1/2 to the x. But 1/2 to the x is 2 to the power of -x though. So x equals to -1. So this is -1 also. So the graph, to be more precise, then we'll have x-intercept -1, 0, y-intercept 0, -1. Horizontal asymptote, y equals to -2. Okay, go on further. Some technicality. Question number 16a. GT equals to sine of e to the -t. Find the domain. Find the domain. Well, the domain of e to the -t is all real number. Right? It's all the t where t is all real numbers. So I can just say the domain is all real numbers. Okay, so and sine is continuous everywhere anyway, so the domain of sine of gt therefore will be all real numbers anyway. Now, however, how about part B, where gt is square root of 1 minus 2 to the t. Now that's the square root, right? Okay, so the domain of gt must be all the t where 1 minus 2 to the t to be greater or equals to 0. Right? Now let's solve that though. 1 minus 2 to the t greater or equals to 0. 1 greater or equals to 2 to the t. But 1 is 2 to the 0. So t has to be less than or equals to 0. So the domain of gt is -infinity up to 0, including 0 in interval notation. Number 23, 24. Number 23, limit when x goes to infinity of 1.001 to the x. What will that be? Because the base is greater than 1, then a to the x will go to infinity as x goes to infinity, right? Okay, and a to the x goes to 0, not negative infinity, as x goes to negative infinity. Basically, the graph actually looks like this because the base is greater than 1, so it will be increasing. Maybe it's very, very slow in increasing, but it is increasing regardless. Okay, it is increasing. So when you go very far to the left, the limit will be 0. When you go very far to the right, the limit will be positive infinity. So this is positive infinity here. Limit x going to negative infinity of 1.001 to the x is 0. Now the thing is, how about I would really like to do number 26 though. Number 25, even though that's an odd number. Number 25, limit x goes to infinity of e to the 3x minus e to the negative 3x over e to the 3x plus e to the negative 3x. How would we do this? I think what I will do is, one thing you cannot do is the following though. Some of you may say, oh, this becomes 0, right? This becomes 0, right? So this is limit x going to infinity of e to the 3x over e to the 3x. That's equals to 1. Now, if you did it this way, you make at least 2 mistakes. Very crucial mistakes. You make at least 2 very crucial mistakes. Okay? The first step that you did there, if you did it this way, you make a mistake where you apply the x, you apply the limit x going to infinity to only part of that, only for these 2 terms, while if you do so, you're supposed to apply to every axis, not only part of that. Okay, what you did here is discriminatory. No, you cannot do that. Okay, the second mistake you have here in your second step is, once in a step you suddenly get rid of the limit notation, it means you apply the infinity here. Okay, but when you apply infinity to e to the 3x, that's infinity. And you are saying infinity over infinity is equals to 1. That's not true. Infinity over infinity is not 1. It's actually undefined. We don't know which one is larger. Okay, so this method of showing work is very incorrect. Very, very incorrect. So how should I do that, Thomas? Well, one thing we can do is we multiply by e to the 3x and e to the 3x. I think that's what I will do first. Okay, I wonder if it helps. So this will become e to the 6x minus 1. And this is e to the 6x plus 1. And how do we proceed from here? Any idea? The answer is 1. The answer is 1. But how do we go on from this step to that step? Anybody? So instead of multiply the top and the bottom by e to the 3x, we multiply by e to the negative 3x. Number 28, take a look on the explanation. Okay, so basically I modified what we have here to be something looks like that here. Okay, it's easier to work. Then I introduce I just give the formula right away. The derivative of e to the x with respect to x is e to the x, and apply that to some problems. Okay, and the last box there is the chain rule, which we will apply to number 36 and number 44. Number 36, y prime is equals to, let me write it this way so that you can follow, e to the negative 2t prime cosine 4t plus e to the negative 2t times the derivative of cosine 4t. And the derivative of e to the negative 2t is itself times derivative of negative 2t, which is negative 2 cosine 4t plus e to the negative 2t times the derivative of cosine 4t is negative 4 sine 4t. Okay. And then let me factor negative 2 e to the negative 2t out. So I get cosine 4t here plus 2 sine 4t. That's number 36. Number 44, y prime is equal to e to some power. The derivative is the same thing times the derivative of that thing, the u. Okay, let me just write it that way for now. And then, so I write the chain first and then simplify or compute the derivative of k tangent square root of x. What is the derivative of tangent?
Secant squared.
Secant squared, square root of x, times the chain rule, right? The square root of the derivative of square root of x is 1 over 2 square root of x. Okay, so this is equals to y prime is equals to k square root of x secant square root of x over 2x. I rationalize the denominator right away. Times e to the k tangent square root of x. Okay, that's for number 44. How about number, I wonder what else, how about number 54? Number 54, hold on, I get a text. Will you mark points off if we don't rationalize the denominator? When the question is this simple, I will. Yeah, when the question is this simple, I will. Yeah, that's usually because you don't really rewrite it, make it in a nicer situation. Okay, but I understand some cases it's way too complicated, such that you just leave it like that. But for this simple one, yes, I will penalize. Okay, number 54, find the equation of the tangent line to x e to the y plus y e to the x equals 1 at 0, 1. We need to use implicit differentiation. When I apply implicit differentiation, okay, that will be e to the y plus x e to the y times y prime plus, so derivative of this becomes this, right? And then derivative of this becomes y prime e to the x plus y e to the x equals to 0. Okay. Now, we know that when x equals to 0, the y is 1. When x equals to 0, the y is 1. So at 0, 1, this will be e to the 1 plus 0 plus y prime e to the 0, which is 1, plus y is 1, e to the 0 is 1. So e plus y prime plus 1 equals 0. Y prime equals to negative e minus 1. That's the slope only. That's the slope only. So what is the equation of the tangent line? So the equation of tangent line will be well, by the way, we happen to have a y-intercept here, right? If you think about it, there's a y-intercept. Okay, so it will be y equals to the slope negative e plus 1 x plus 1, right? Because this is the slope. Okay, and that's the y-intercept. Yeah, otherwise, then you need to plug in x equals 0 to find the y-intercept. That's number 54. The next, a lot of questions after this, basically the application of this derivative. Now, but let me just go ahead with the integral. Because the derivative of e to the x respect to x is e to the x, then the integral of e to the x respect to x will be e to the x plus constant. Okay, now then using this, how do we answer or do integral problems? How do we do integral problems? For example, number 82, integral of x squared times e to the x cubed dx. What do we do? Okay, I do it myself then. Do u sub, right? Okay, because we can integrate e to the x, we cannot integrate e to the x cubed. So the way we think is like, okay, I cannot integrate that because we have that ugly x cubed there. So what happens if you are ugly? Substitute. Okay, that's why they call that u. Okay, that's the substitute. Okay. What do you do to an ugly person in your life? Substitute. Okay, so u is x cubed, and the u is 3x squared dx, such that x squared dx is du over 3. Now then, that integral becomes e to the u du over 3. Now, integral of e to the u respect to u is e to the u. Then I substitute that back. Okay. Let me ask you to try question number 84. Integral of 1 plus e to the x squared, am I recording this? Yeah. Over e to the x dx. My suggestion for you is to FOIL the top first and then divide by e to the x. And after that, you integrate one by one. You simplify first and then integrate one by one. So this is e to the negative x plus 2 plus e to the x dx. I hope you see that now. This is e to the negative of e to the negative x plus 2x plus e to the x plus constant. There are some technique of integration I would like you to already know from now on to speed up your computation. Okay, let me use different color so that you see what the difference. Okay, what I want to do is this. Let me use blue color. Note. If integral of fx dx equals to capital F x plus constant. So if fx is the antiderivative of lowercase fx, then what happened to integral of f ax if you have coefficient for that x? Then the answer will be f(a)x over a plus c. Okay, now we can actually prove this, but I just want to show you that that's actually the reason I can do this computation fast. That's actually the reason I can do this computation fast. Okay, otherwise you need to show another u sub for your integration. But in general, you will see the following situation. Proof. Let u equals to ax. So du equals to a dx. Right? Therefore, du over a will be used to substitute dx. So now our integral of f of ax dx now can be substituted to be f integral of fu du over a. But this is 1 over a f capital U plus constant, which is 1 over a f(ax) plus constant. Now that will actually help your computation a lot faster. A lot faster. Instead of like you need to do u sub every time you have 2x there or 3x there. Come on. You know. Okay. So using that idea, let's see how would we do number 90. Integral from 0 to 1 of square root of 1 plus e to the negative x over e to the x dx. We'll do u sub here. My u will be 1 plus e to the negative x. So my du will be negative e to the negative x dx. But this basically means I can substitute my dx over e to the negative x over e to the x as negative du. Right? Okay, these two guys here, the product of these two guys here is the same to this. Okay, but at the same time, since I do that u substitution on a definite integral, then at the same time, I need to change the limit of my integration. So u0 will be 1 plus e to the 0, that's 1. u1 will be 1 plus e to the negative 1. Okay, so this becomes integral from 2 to 1 plus e to the negative 1 of u to the power of 1/2 negative du. Okay, I don't like that negative coefficient. I absorb that negative by reversing the limits of integration. Okay, now I think then you can take it from there. Is that right? This is 2/3 u to the power of 1/2. 1 plus e to the negative 1, 2. It's 2/3. 2 square root of 2 minus 1 plus L1 over e square root of 1 plus 1 over e. You're supposed to rationalize that though. This is an e. Okay, and from here just simplify that. That's for number 90. I wonder if there's other question of your interest. Oh, I think number 99 is interesting. I like it. Number 99. I usually don't do even number, but this one seems to be interesting. So number 99, fx equals to 3 plus x plus e to the x. The question is, find f inverse, derivative of f inverse at 4. Ooh, long time no see. So this is equals to, according to what we learned last time on Monday, this is 1 over f prime of f inverse at 4. Okay. Right, that's what we need. So first step, what is f inverse of 4? If I call that x, then 4 equals to fx, which is 3 plus x plus e to the x. I think it is 0, huh? So x equals to 0. Then second step, let me continue here. Second step, what is f prime x? F prime x would be 1 plus e to the x, such that f prime 0 will be 1 plus 1, which is 2. Then f inverse, the derivative of f inverse at 4, therefore is 1 over f prime of f inverse at 4. That is 1 over f prime at 0, but that's 1/2. Okay. Let me give you suggested homework from here. Suggested homework from 6.2. Number 3, number 15, 23 to 59, 69 seems to be an interesting problem. Important one, 79 to 93. Number 103 is also interesting. It's very conceptual. It's very conceptual. Think about that one question. Okay. Now 6.3. So this is 6.2a. B. And the next section I will do is 6.3. Now 6.3 is more into review. But before I do that, let's take a little break. My hand's kind of tired. Let's take a little break. We come back at 8:25. Let's continue. 6.3 on logarithmic function. Now this section is more into reviewing our precalculus. It is more into reviewing our precalculus. Now let's see, what do we need to review? Now for positive base, which is not 1, then log base a of x equals to y if and only if a to the y equals to x. So log function is the inverse of exponential function. Properties of log. Some of them quite basic, but I just go ahead with the 3 major properties of logs. Log base a of product equals to sum of logs. I need to say that the base is positive and not 1. At the same time, the argument x, m, and n has to be a positive real number. It has to be positive. Now, that's because the domain of log is positive. Maybe I write it down. The domain of log base a of x is 0 to infinity. Okay, let's see. Can anybody tell me why? Nobody? Okay, I go over that later on then. And over then log of quotient equals to difference of logs. And then log base a of m to the r equals to r log base a of m. Okay, Now the consequence, one of the big consequence is then, this is more into basic properties. Log base A of 1 is 0. Log base A of A is 1. Or in general, log base A of A to the n equals to n. Also, A to the power of log base A of x equals to x. Now, I don't think I want to go over the proof of this. If you want to, take a look in your pre-calculus textbook, okay? Yeah, go look at your pre-calculus textbook. But the domain and range of log function has a lot to do with the fact that log is the inverse of exponential function. Let me say it this way. Theorem, let fx equals to a to the x, where the a is positive and not 1. Then inverse function of fx will be log base a of x. The proof is actually quite simple. It's the consequence that you need to be aware of. So step 1, to find inverse function, y equals to a to the x, right? Step 2, I swap the x and the y. Step 3, I apply the log. And step 4, f inverse x equals to log base a of x. Okay, now it's the consequence that is important. Why? Because the domain, if I have, maybe I write it this way. So if I have fx equals to a to the x, the domain is all real numbers. And the range is from 0 to infinity. Okay, now then, the inverse function, let's call that gx now, of log base a of x must have domain equal to the range of the original function. We learned this last time. And the range of log function is the same to the domain of the original exponential function. Now, in fact, we also know that the asymptote, we have horizontal asymptote, is y equals to 0. Okay, now that horizontal asymptote, when you do the inversing, becomes vertical asymptote. Vertical asymptote x equals 0. Okay, that becomes a foundation for our big work later on. Yeah, suppose if the a is greater than 1, if the base is greater than 1, the exponential function is increasing, right? Then the log function, when a is 1, greater than 1, it's also increasing. Okay, but notice that as we approach 0 from positive side, limit x approaching 0 from the right hand side of log base a of x, that will go to negative infinity. Okay, while if the base is between 0 to 1, the exponential function will be decreasing such that the log version will also be decreasing, but it looks like this. Where the limit when x approaching 0 from the right hand side of log base a of x will be positive infinity. Okay, now that's for log. What happens if we have base e? Log base e of x is basically natural log of x. Okay, that's actually a definition of natural log of x. Now we will use this. We will use this to solve problems from this 6.3. Again, this is basically a review. For example, exercise number 4. Part A, natural log of 1 over e is natural log of 1 over e is natural log of 1 minus natural log of e. What is natural log of 1? Zero, right? Minus natural log of e, and we know natural log has base e, so this is actually -1. Okay, but actually we can say more. Log base a of x over y, if you do the reciprocal, you get the negative of that. Negative of log base a of y over x. Okay, so we can actually do it this way. If you think about this, this is the first method, right? The second method, this is actually natural log of e to the power of -1. That's -1. Yeah, because the base for the logarithm and the base in the argument are the same. Both of them base e. Right? So in some sense they cancel, we get -1. Part B. What is log base 10 of square root of 10? Now usually if it is base 10, we don't even write the base anymore. Okay, in other words, if you see log with log x without any base, it means implicitly it is base 10. Okay, please keep that in mind. How to do this one? This is log base 10 of 10 to the 1/2, which is 1/2 according to our basic property here. This one, that's what I use. That's for number 4B. How about number 6A? Number 6A, log base 1.5 of 2.25. What is that equals to? This is log base 1.5 of 1.5 squared. So yeah, 2.25 is 1.5 squared. Okay. Part B, log base 5 of 4 minus log base 5 of 500. That's log base 5 of, there are actually a couple ways to do this. Let me call this the first way, the standard way. This is 4 over 500, which if we reduce, I get log base 5 of 1 over 1.5, which is log base 5 of 5 to the negative 3, so the answer is negative 3. Okay, but there's another way to do this. There's another way to do this. The second method is breaking that 500. This is log base 5 of 4 minus parentheses log base 5 of 4 times 125, which is log base 5 of 4 minus log base 5 of 4 plus log base 5 of 125. Fast forward, we will see this will give us negative 3 also. Number 10, use the properties of logarithms. Use the properties of logarithms to simplify or to expand the quantity. Number 10, log of square root of x plus x minus 1 over x plus 1. Ooh, wow. How to do this one? That's to the power of 1/2, right? Okay, so let me rewrite it a little bit. I hope you see that this is x minus 1 over x plus 1 to the power of 1/2, right? And according to property number 3, I can bring it to the front, right? Which is 1/2 of log x minus 1 minus log x plus 1. And distribute the 1/2. This is not the only way to do that though. This is actually not the only way to do this. This is one way. Okay, another way to do this, if I call that the first method, the second method, you distribute the square root first. So this is square root of x minus 1 over square root of x plus 1. Okay, and then you use property number 2, log of square root of x minus 1 minus log of square root of x plus 1. And then the exponent 1/2, you bring it to the front. Okay, but I think at this point I need to remind you, in your pre-calculus, your teacher is supposed to teach you a faster way to break down a logarithm. So let's say, for example, I have log base a of x cubed y to the 4th over c to the 5th w to the 7th. Okay. Now, I hope you can do it in your mind and skip all the steps and get this. You see, you will get x and y are on the top, right? Multiplication on the top, okay? Such that it will have positive coefficient with the coefficient to be the exponent. So the exponent becomes the coefficient 3 log base a of x plus 4 log base a of y minus 5 log base a of z minus 7 log base a of w. Okay, do it in one single strike. Now, once you are able to actually break it up that fast, and hopefully, when we need to put them together, we can do it almost at the same speed. Number 14, log 4 plus log a minus 1/3 log a plus 1. Put it in single log. 4 has positive coefficient, it is on the top. A positive coefficient, it is on the top. And negative 1/3, make it on the denominator. That's the cube root of a plus 1. Dang, only one step, Thomas. Now, how about solving some equations? Number 28. Number 28, part A. Natural log of x squared minus 1 equals to 3. Solve for x. This is a log form. I will change this into exponential form. In exponential form, so x squared minus 1 equals to e to the third. And then I add 1 both sides. Apply the square root property. Don't forget the plus minus sign. Okay. Now, of course, I'm supposed to check if it works, but we know it works here for any x, right? All you need is actually x squared minus 1 to be positive. Okay, x squared minus 1 is positive. That's x cubed. How about part B? E to the 2x minus 3 e to the x plus 2 equals to 0. How do we solve this? I think I will use substitution so that we can see better. U equals to e to the x, right? Such that this becomes u squared minus 3u plus 2 equals to 0. And then I factor u minus 2, u minus 1 equals to 0. So u equals to 2 or u equals to 1. Change it back, e to the x equals to 2. So x is natural log of 2. E to the x equals to 1. So x equals to, oh, just 0, right? E to the 0 is 1. Can I ask you to do number 32 and number 34? Number 32, 10 times 1 plus e to the negative x to the power of negative 1 equals to 3. Solve for x. And then, actually, instead of number 34, do number 36. 36, natural log of 2x plus 1 equals to 2 minus natural log of x. The first one, I think in both cases you need calculator, but give me the exact form first. Don't use calculator first. Okay, I mean, in other words, you can leave your answer as ln 2, or you can leave your answer like this. Okay, let me give you how many minutes for each. I think 3 minutes for each. So I'll be back in at 8:55. 6 minutes, 3 minutes for each. Try. Okay, let me start. This is 1 plus e to the negative x to the power of negative 1 equals to 3/10. But this is 1 over, right? 1 plus e to the negative x equals to 3/10. I will do the reciprocal both sides. And 1 plus e to the negative x equals to n/3. Subtract by 1, it will give me 7/3. Now I apply log form. So natural log of 7/3 is negative x. So x equals to negative natural log of 7/3, which I can also say that's actually natural log of 3/7. Okay, number 36. I move the ln x to this side. The purpose is so that I can change that into a single log. This is natural log of 2x squared plus x equals to 2. Therefore, 2x squared plus x equals to e squared. Right? Okay, let me set it equals to 0. And then I think I will apply quadratic formula. So this will be negative b plus minus square root of b squared minus 4ac. Actually, 2 times 2. So I get negative 1 plus minus square root of 1 plus 8e squared over 4. Okay, now the thing is, we have 2 solutions here. One, the positive branch, which I believe will work. Okay, because when you plug that in, the argument has to be positive. Okay, yeah, it has to be positive. Now the thing is, the second x will give us a negative value. The numerator is negative. You see that? So I have to cancel it. Okay, I have to cancel it, and this is the only solution. This is the only solution. Now that's for solving equations. That's for solving equations. How about using calculator? Like question number 38b. Yeah, actually, just similar to other questions, but this time I want to show you how to use calculator. This is 3 to the power of 1 over x minus 4 equals to 7. We can use log base 3, we can use log base 7, we can use log base 10, we can use natural log. Let me apply natural log. Okay, so I apply natural log on both sides. That will give me 1 over x minus 4 of ln 3 equals to natural log of 7. Okay, Then natural log of 3 over natural log of 7 equals to x minus 4. I wonder if you can see that. I bring this to the right hand side, so it is on the top. ln 7, I bring it down. Okay, so x is now equal to 4 plus natural log of 3 over natural log of 7. Then you use your calculator. I hope you know how to use your calculator. Natural log of 3, close parenthesis, divided by natural log of 7, whatever that is, plus 4. I get, if you use calculator in my class, round it to 5 decimal places. So this will be 4.56458. At least 5 decimal places. Okay, now I would like to make sure that all of you actually knows how to use your calculator. Are you okay? Do you need me to show you how to use your calculator? Nobody say anything. Okay, fine. Furthermore, how to deal with inequality, number 48. We have 1 less than e to the 3x minus 1 less than 2. Now remember, exponential function is a one-to-one function. It's a one-to-one function and it is increasing if the base is positive. So in that case, I can apply natural log all to 3 sides at once. Okay, I apply natural log to all 3 sides. This is 0 less than 3x minus 1 less than natural log of 2. I add 1 divided by 3, so 1/3 less than x less than 1 plus natural log of 2 over 3. However, you need to be careful if the base, if the base is between 0 to 1. Suppose, for example, I change the question. 1 is less than, let's say, 1 over 2 to the power of 3x minus 1, 2. Now, if you dare enough to play with a base less than 1, okay, which is fine, but just careful. Okay? If you apply base less than 1, exponential function with base less than 1 is decreasing. So when you apply the log of base less than 1, positive but less than 1, you need to reverse the inequality sign. Okay? And I wonder if you know that this is -1. Okay? And then so on and so forth. So on and so forth. If you apply log base 1/2, if you apply natural log, then you don't have to, even though your answer will be very, very complicated if you do so. Okay, here the choice of base 1/2 will be appropriate, or actually base 2 will also work. If you make it into base 2, you will see that what we did there is actually correct. Okay, let me just show you that. So I can write this as 2 to the power of negative 3x minus 1. And I apply base 2. This is 0. This is 1. Okay, move the negative. This is where the inequality change. Right? Okay, I hope that confirmed that. Yeah, you can solve it yourself there. Furthermore, how about the limit? So a bit more before I give myself a little more break. Number 48, an interesting question. Actually, I myself get stuck a little bit with this question in the past. Like I know the answer, but I don't know how to show it. And if I were the student, then I won't get any point. So I need to show you, my student, how to show the work systematically to get the answer with x minus x to the 4. Let me play around with the expression first. This is, I'm sorry, this is not log. Why I keep on writing log there? It's supposed to be limit. So this is limit x approaching 2 from the left hand side of log base 5 of, let me factor the x out from there. Okay, so this is equal to log limit. That's limit x approaching 2 from the left hand side of log base 5 of x plus log base 5 of 8 minus x cubed. You're right? Now the thing is that I can distribute the limit. Yeah, because the limit here exists, right? The limit there exists. So limit x going to 2 from the left hand side of log base 5 of x plus limit x going to 2 on the left hand side of log base 5 of 8 minus x cubed. Now the one on the left hand side, this is log base 5 of 2. Okay. The problem here, we have issue here. Okay. Now let's do the side. X going to 2 from the left hand side. So you can imagine it this way. This is 2, but your x is actually slightly to the left of that. Okay, slightly to the left of that. So what happened to x cubed? Will be approaching 8 from the left hand side also, right? If it is almost 2, when you square, when you take it to the power of 3, then it will be almost 8. Okay. Now then, what happened if I put negative x cubed? Then it will be going to negative 8 from the right hand side because you reflect that, right? Okay, and then you add 8. But this is 0 positive. Can you explain why you put negative? Because I'm chasing this form. I'm chasing this. I'm trying to chase this. Okay. Yeah, I'm trying. Oh, there's another passage. We don't have to show all that work through though. Is it right? You don't have to show all the work. I need you to show me this at least. The things that you need to show is you need to show me that this implies this 8 minus x cubed approaching 0 from the right hand side. That's what I need you to show me. Okay. So basically then we now have this is limit x 8 minus x cubed approaching 0 positive of log base 5 of 8 minus x cubed. But log, maybe I write it this way then. This is log base 5 of 2 plus log limit of u going to 0 positive of log base 5 of u. From what we learned before, what will this be? What will this be? That's negative infinity. Remember that? Okay. Now, let's go on. Another limit question. I think number 50 is another interesting question. Number 50. Number 50. Limit of x approaching 0 from positive side of natural log of sine x. Now, we will play this way. I will play this way. If x approaching 0 from the positive side, what happened to sine x? So you need to remember what the graph of sine x, right? Especially the one surrounding 0. So if you're approaching that 0 from the right-hand side, then sine x will be going to 0 from above, right? So in other words, you can now write it this way. This is limit sine x approaching 0 positive of natural log of sine x. Okay, so limit. You don't need this last step though, but just to show you what actually happened. So this will be negative infinity. Okay. Number 52. Number 52. Limit of x going to infinity of the quantity natural log of 2 plus x minus natural log of x. I will put them together first. This is limit x going to infinity of natural log of 2 plus x over 1 plus x. This is equal to now, I don't want you to give me the final answer right away because you need to show me the detail. How will you do this work? What will your next step be? Let's see. I will move the ln out of limit x going to infinity of 2 plus x over 1 plus x. Actually, you don't need to do that, but the following is the key step. You cannot plug in x right away. You cannot plug in x right away from here. No. Thomas, can I use L'Hopital rule? No, you cannot because we have not learned it. Right? Don't use L'Hopital rule. Don't use L'Hopital rule. But how do we actually answer this type of question in Calculus 1? Divide by x, right? Because x goes to infinity, right? So we divide by x on the top and the bottom, 2 over x plus 1 over 1 over x plus 1. Then when we apply the limit, we will get 0 plus 1 over 0 plus 1, which is 1. Therefore, natural log of 1 is 0. That's the proper way to do it. Okay, that's the proper way to do it. Factor out an x and cancel it. Okay, that makes sense. That's for number 52. Find the domain of functions, number 54. So find the domain of find the domain of fx equals to natural log of x plus natural log of 2 minus x. Oh, very good question. Yeah, the summation of two functions, right? The summation of ln x and ln of 2 minus x requires the domain of f to be the intersection of the domains. So the first one has to be greater 0 or positive. Greater than 0. Intersect with 2 minus x has to be positive, implies x has to be less than 2. Therefore, the domain is 0 to 2 only. You cannot plug in anything outside of this. Okay. Now, that brings me to one issue that, in my opinion, very crucial. And plenty of students didn't realize this. For example, find the domain of fx equals to natural log of x plus natural log of x plus 2. Now compare that with fx, maybe I call it gx instead. Compare that with gx equals to natural log of x squared plus 2x. This is part A. This is part B. Okay. Now I want you to realize that we learn in the property of logarithm that this expression here is the same to the expression here. Okay, but you will see that the domain are different. Okay, you will see the domain are different. Because in fact, they are not exactly the same. They are not exactly the same. Okay, they are not exactly the same. But why? You will see when you show the work, of course. In here, the domain has to be the domain has to be greater than 0 and greater than -2, right? Therefore, the intersection will give us greater than 0. Okay, pictorially, this guy here has to be greater than 0, and the one here has to be greater than -2. Greater than 0 and greater than -2, the intersection therefore greater than 0. But what happened on the right hand side, x squared plus 2x has to be greater than 0. Okay, let me complete the square. Actually, I don't need to do it. How to solve nonlinear inequality? So step 1, critical numbers, nonlinear inequality. So x squared plus 2x equals to 0, x plus 2 equals to 0, x equals to 0, or x equals to -2. And then I do the sine graph. -2, 0, both of them the zeros, so I get positive, negative, positive. So the solution is, the domain will be from -infinity up to -2 union 0 to infinity. What happened is the following. What happened is the domain on the right hand side here is larger than the domain of the left hand side. Why? What happened here, both x and x plus 2, each one of them has to be positive. While the right hand side, they don't have to be each one of them positive. What they need is only that the product is positive. So the product may be positive if x and x plus 2 both positive, right? That's the case for x greater than 0, or if both of them negative, and therefore the product is positive. Okay, so they look the same, but again, the devil is in the detail. Let's see. Can I explain that again? It has something to do with the requirement that the argument has to be positive. What happened here? The x has to be positive. X plus 2 also have to be positive. So both of them has to be positive. Now what happened here? What you need is the product to be positive. Okay, the product has to be positive. But the product can be positive if both of them positive, either x and x plus 2 positive, or both of them negative, x and x plus 2 is negative. So for example, if you choose x equals to -5, right? So this is -5 squared plus 2 times -5. That will be natural log of 25 minus 10. That's natural log of 15. Then it works, right? Then -5 in the domain. However, it doesn't work here. Natural log of -5 is undefined. Natural log of -7 is undefined. I'm sorry, -3 is undefined. Okay. Now the issue of domain is something very, very big in pre-calculus. So I'm glad, just let you know that I'm actually very happy that one of my pre-calculus students actually taking my class. Should I tell your name? Oh, no, he's not here now. I wonder if he dropped the class. No, he's here, yeah. He's here. No, he got an A from my pre-calculus. So this guy is actually a good, a smart guy. If you can get an A from me, you must be in my pre-calculus. Then you must be someone, okay? And I look up to my A very much. Okay, let's take a look on number 56. Let's take a look on number 56. The question is, find the domain of the function and the inverse and the domain of the inverse. So let fx equals to natural log of 2 plus natural log of x. Part A, what's the domain? Well, there are two things we need to satisfy. First, 2 plus ln x has to be positive, right? This guy here has to be positive. And of course, this guy here, just this one, has to be positive also. And ln x has to be, I'm sorry, x has to be positive. Okay, so ln x is greater than -2. Ln is increasing, so x has to be greater than e to the -2, which is already positive. So x is greater than 1 over e squared. Domain is parentheses 1 over e squared, comma, infinity. This is a square. Part B, how about the inverse function? Step 1, change the fx to y. Step 2, swap the x and the y. Step 3, solve for y. So this is e to the x equals to 2 plus ln y. E to the x minus 2 equals to ln y. So y is equals to e to the x minus 2. So f inverse x is e to the x minus 2. Now, part C, what is the domain of f inverse x? What kind of x are you allowed to plug in? Any x, right? You can plug in any x. Is it okay? You can plug in any x. Now, which, if you think about it, this is basically asking what's the range of the original function. It implies the range of the original function is actually all real numbers. That's how you actually show it. Because without doing that, everything, if I ask you what is the range of this fx here, what's the range of this fx here, without showing those words, then you will say, and you suddenly come up with all real numbers, then you do it by instinct only, without too much explanation. Okay? Now, that's for number 56. Let me see more. I do a lot of problems here. Number 62. Last one before I move to 6.4, at least the beginning part. Number 62. Find the inverse function of, so it has to be inverse function, not only inverse, of y equals to ln x squared for x greater equals to 1. Step 1 implicitly done. Solution. Step 1 implicitly done. Okay, step 2. You swipe the x and the y. Okay, but again, the detail is the devil is in the detail, right? So x has to be greater than 1 here. Here, the y therefore becomes, you swipe the x and y, right? The y has to be greater than 1, greater equals to 1. Now then, if y is greater equals to 1, then the square root will be positive. Is it right? This has to be positive. Maybe I put it this way. Let me put it this way. So I will use plus minus here for now. Right? But at the same time, we know that ln y will be greater equals to ln 1, which means ln y is greater equals to 0. That's how then the negative sign fell off. Therefore, what am I doing? Then e to the square root of x equals to 1. Okay, we cannot keep ln y equals to plus minus. No, we cannot. We cannot. Why? Because then it becomes not a function anymore. Okay, and the reason they give us this restriction so that we take only one branch because they need to be one-to-one. Otherwise, it's not inverse function. Okay, so it's step 4, then inverse function, let me call that f inverse x equals to e to the square root of x. Okay. You know what? I want to take a little break. How about you do number 64? Woohoo! That's nice. Down here. Number 64. Maybe I use fx. So define the function fx equals to e to the x over 1 plus 2 e to the x. Find inverse function of x. Okay, let me give you maybe 5 minutes. Okay, let's start. Step 1. Oops. So solution. Step 1, I change the fx to y e to the x over 1 plus 2 e to the x. You can actually think of this e to the x as your u. You solve for u first. Okay, you can think of it that way. So I will swap the x equals to e to the y over 1 plus 2 e to the y. Step 3, x plus 2x e to the y equals to e to the y. So x equals to e to the y minus 2x e to the y, factor e to the y, and then divide. And then apply natural log. Basically, I change it into log form. So my step 4, f inverse x is natural log of x over 1 minus 2x. Okay, now let's close this section with the suggested homework. 6.3, number 3 to number 17, number 25 to number 39, number 47 to number 65, maybe 67. Okay, that's for 6.3. Now, as an introduction to 6.4, to prepare for 6.4, actually, that's the only thing we need to do, and then everything else just application. For 6.4, we want to find the derivative of natural log of x. Okay, the derivative of natural log of x respect to x, so that on Wednesday next week I don't need to prove this anymore, is 1 over x. The derivative of natural log of x respect to x is 1 over x. Proof. Let y equals to natural log of x. So e to the y equals to x. Now apply implicit differentiation. We will get e to the y times y prime equals to 1. So y prime equals to 1 over e to the y, which is 1 over x. So derivative of the y prime is dy dx, that's d of natural log of x respect to x equals to 1 over x. Okay, that's the proof. Now, the consequence is a lot though. It's a lot of consequence. From here, we open a new, a very, very big case. Basically, then it also, the big consequence directly is that the derivative of natural log of u respect to x is 1 over u times du dx. Okay, that's one big thing we will apply on Wednesday next week. Okay, so next week, when we start the class, we basically do derivative of natural log right away. And then we go on further to the integral and logarithmic differentiation. I think this is where I will stop for today. See you on Wednesday.